My dear students, and welcome to the chemistry laboratory. This is the obligatory safety lecture that you have in every lab all the times. It's less important, obviously, in a virtual lab where we'll be doing, you're going to live and learn vicariously through me as I perform experiments, as I discuss and manipulate data in a good way, do calculations and solve problems with data. And you're going to be visiting other websites and doing online labs and the like. But we still need to make sure that you gain exposure to, experience with, and knowledge of standard laboratory procedures, protocols, familiarity with equipment, and various chemical tests typical of a freshman qualitative analysis course. So, one of the things most people use, not most, but probably certainly in the K-12 system and less so at the college, but many people use, is the Flynn Scientific Corporation Science Safety Contract. And some of them are broadly written to include biology, physics, and chemistry labs. I'll stick to the chemistry aspects of it. And if you plan to go on, if you're going to be an education major or go on in biology or chemistry or sciences in general, and you're going to be teaching, they have wonderful resources for you, including science safety contracts. I have quite a few of them up here on their website. I went ahead and went to the science safety part, and you'll see elementary, middle school, high school, and college lab safety contracts. It's just a list of common sense, but also very specific to the discipline, procedures, standard operating procedures, if you will, SOPs if you're military, or I guess hints and the like of how to stay safe in the lab, because if there's one thing that keeps me awake at night, it's your safety. So we're going to go over this college safety lab contract. If you're going to be a teacher, some of you'll see there are even quizzes for your students and much more detail. Some people even that I know teaching in other schools use up a week, 2 or 3 lectures covering this. We're going to go very quickly over the science safety contract with a few demos. I want you to pay attention and watch what I do, especially in the quick demonstration I'm going to do, because I'm going to ask you a discussion question about it in your quote-unquote lab report over this. Let me go to the computer and pull up the college science safety contract here in a safety in the chemistry lab, student safety guidelines and agreement. We're not going to have you sign this contract, but we are going to discuss it and cover this material. Somewhere I have a pair of glasses so I can read it myself with my reading glasses. And anyway, I forgot. The other thing I wanted to do was turn off my phone, but we'll find it in a minute. If you look at this, and I've posted a PDF copy of this into this lab module, and you'll see it says, be prepared for lab. Obviously, that was very important. In the old days, on your lab report or your lab notebook, we had you rewrite the procedure. It was really just busy work, but it was a way to drive home that you need to be familiar with what you're going to be doing in lab. Pay attention during the demo part, or, depending on what kind of old school person and instructor you get. Write it down and just do what you're asked. Read the procedures carefully before your scheduled lab period. Follow all written and verbal instructions. Do not perform unauthorized experiments and never work alone. This is one problem I have all the time is people say, what would happen if I do this? You know, combine these two solutions or something. And I have several answers, but most of the time I'm going to say try it. But not all the time, because sometimes it's a really bad idea to do side experiments or not follow the instructions precisely, although we'll generally give you a warning about that. Do not eat, drink, or chew gum in the laboratory. Food-grade items brought into the lab for testing or analysis are considered laboratory chemicals. Follow me if you would, please. For example, one of the things we do is an analysis of cereal for iron content. And we do have things in the lab that are arguably consumables. The other thing is, we just don't want you to be contaminated, harmed with chemicals. So if I can get my videographer to stop zooming in and out and changing, but just follow me in general, okay? So back up and make sure they can see this up here too. That's good. The thing is, if you're like me and you wear contacts or you have allergies and you rub your eye or your hands aren't clean, I wash my hands when I come into the lab and when I leave the lab. I also wash them frequently during the day working in the lab. In fact, so frequently that my hands dry out, I'm always putting lotion in the like on my eyes. But if you handle chemicals and then, you know, your eye itches or you rub your eye or you know, I don't know, contaminate yourself, that's really bad. So don't eat. Don't be handsy, okay? Know the locations of all exits as well as safety equipment in the lab, including and not limited to fire extinguishers, fire safety blankets, safety showers, and eye wash stations. They're all marked, okay? So follow me but at a distance. Here is a fire extinguisher and a fire blanket. Here's another fire blanket. Some of them are just wool. They put you out. If you catch yourself on fire, do not run to the fire blanket. Just scream and I'll get the fire blanket and run to you. Because what do you do if you're on fire? I can hear you all going, stop, drop, and roll. Some of you paid attention in kindergarten. There are fire extinguishers. I have one on this side of the lab. I have one over here. Let's go this way and talk about safety equipment. Follow me into the next room and stay a little closer to me. Come on. And the other fire extinguisher and fire blanket is right here. Those are all bright red, okay? Also, I want you to look at this material data safety sheets book. And if you look around, you'll see all kinds of safety equipment. Here's our goggle sterilizer with some extra goggles that haven't been sterilized. It's a locking cabinet because it has an ultraviolet light. You shouldn't look at ultraviolet light. That I use to sterilize the class goggles. Best thing to do, and what many schools require, is you just buy your own pair of safety goggles. That way, you're the only one doing it. This lab, it's taken apart for maintenance right now, has an eye wash station, hand washing stations. Don't tell my wife, but here's the hand lotion. This is the good stuff. But anyway, hand washing stations, paper towels, first aid kits here, there, over there. I've got 3 first aid kits in the lab. All kinds of safety equipment. And you're just beginning to see some of it, lab coats and the like. Let's go next door because, you know, this room has 2 exits. Not every room has 2 exits. But obviously, if the fire's over there, you go out that exit. And if the fire's over here, you go out that exit. If it's at both exits, we'll go out the window or we'll make an exit. The other thing is, we have, given the proclivities of the day, We don't want to think about active shooters, but some of my other equipment in the laboratory, safety equipment includes opioid and heroin OD rescue kits to give people Narconon or it's in the nasal inhaler now. I have some of the injectors too stored over there. But this is it's called a Barracuda. It's for locking the door because we have outward opening doors here. And it holds the door closed. Come on over here and follow me. This is the microlab. The people who designed the laboratories here weren't scientists, obviously, but if you look around, again, you'll see fire extinguishers, safety blankets, and what I want you to pay attention over here is chemical fume hoods that we do experiments in where noxious materials give off vapors that need to be vented to the outside. Notice they also have cup sinks in them with water attached, gas as well, and traps to trap things that go down the drain that shouldn't. Over here, besides a hand washing sink again, is two important things. A safety shower. This is not to put people out if they're on fire. We use the blankets for that. You don't run over to the shower and pull the lever. If you spill harmful chemicals, and we never work with most chemistry labs in most colleges, don't work with the levels of chemicals that require that you wash yourself off. But we have had accidents, I've had accidents where a chemical rinse is important. Usually we can settle for the cup sinks, and you have to be careful on these. If you look, there's a floor drain right back there on the floor. Some of these are designed like a flush toilet. You pull the handle and 75 gallons comes out or 25 gallons comes out no matter what you do. This one is a lever action, but I'm not going to demonstrate it. But it's a clear, good safety tool. And the one I use a lot is the eye wash, which sends nice bubbly water up to rinse out your eyes. If you ever get anything in your eyes, we'll talk about this next, you will rinse yourself with the eye wash. I use it, especially here in Arkansas, where it's mainly Missouri's fault with all of their ragweed. I rinse out allergens out of my eyes. It's very refreshing, cool water. If you look in this lab too, you'll see safety kits, fire extinguishers, you'll see all kinds of safety equipment, safety gloves, lab coats, goggles, the works. There's a goggle sterilizer back there in the back corner. So we're going to talk about it later, but while we're doing the tour, here's the broken glass container. You don't throw broken glass in the regular trash. We like our custodians and our staff. We don't want to be dangerous with them, so we throw our glass away separately. That's a broken glass. And of course, this orange is for biohazard, hazardous waste. So let's go back and go over these rules and finish them. And quickly get through this and do a quick demo. So, dress appropriately for the lab, wear closed-toed shoes, long pants, lab coat, or chemical-resistant apron. I don't enforce that too rigorously, but there are many instructors and colleges that rigorously send you home if you have open-toed shoes or sandals. It just depends what we're working with, whether I enforce it, and I usually warn people in advance. Tie back long hair. If you have long hair, I keep hair ties here for my students. If you take one, it's yours, you can keep it. But one of the biggest things I have is people catching their hair, their long hair, in a flame, and for the most part, it'll just burn a strip of it and burn up. But I'll know it happened because if you've ever smelled burning hair, I have some hair in a bag over there that I get from my barber, and she gives me some of the sweepings from her floor so that people can smell what burning hair smells like. It's rich in sulfur, amino acids, and so the keratin protein is, and so lots of disulfide bonds, so it's got a very unique smell. If you wear hair products, hairspray and hair gels and flammable hair gels, you may end up doing a Michael Jackson. And I don't mean to be facetious or insensitive about that, but when he filmed that Pepsi commercial, you should look it up on YouTube. Maybe I'll ask a question about it, where the pyrotechnics in his performance that he was recording set his hair on fire. And they say this may have be what actually killed him. It was then that he started taking the painkillers because he was burned very badly. And it's when he started taking the medications to help him sleep that ultimately led to his death. So, tie long hair back, do not wear long dangling jewelry, ties. My fit for today is a tie given to me by a student last year at the college in DeWitt. They're part of, a big duck hunting region, and the duck capital of the world, I guess, is, and the rice capital of the world is right up the road in Stuttgart. Wear chemical splash goggles. We used to ask people to wear safety glasses with side vents so that nothing comes in the side that covered things. They're very convenient. They do fog up. Everybody hates them the first time they try them on. But after the first week, I have students walk out with them still on. They come back and go, oops, I forgot to leave these here. So you get used to them. So just accept it as a safety factor. These days now, we're really recommending chemically resistant splash goggles because these do not make a tight seal on your face. I have my own because they're more comfortable and more padded, but in general, we will use safety goggles like these. These are 3M safety goggles that we ordered from Flynn Scientific, of all places. Let me continue down this list, and then I will give you a quick test over it, but it's going to be open book, right? Report any accidents or incidents to the instructor immediately, including spills, cuts, burns, contact of chemicals with eyes and skin, because some things don't immediately hurt or burn, okay? Or organic acids, which are weak acids and ionizable, can travel through the hydrophobic skin and then burn inside. Things like phenol leaves a very interesting burn that ultimately causes some nerve damage. But if you spill hydrochloric acid on yourself, you may not notice it right away because, or nitric acid, sulfuric acid depends on the concentration. It's impermeable to your skin, but it's still reacting, just not down into the nerves right away. So just because you can laugh it off doesn't mean I shouldn't know about it. Chemical splash in your eyes, rinse continuously with water for 10 to 15 minutes at the eye wash station. Ask any emergency room physician, EMT, or paramedic. This is the gold standard. It's a long time, but certainly at least 5 minutes, and 10 minutes would be better. Continue rinsing and get medical advice. In case of chemical contact with skin and clothing, remove all contaminated clothing. Ideally, you would be wearing a chemical apron. You can just stay there.
Okay.
maybe even chemical gloves. If it's that much and that bad, I usually don't let the students do it. I only put out small quantities. This, of course, is a chemically resistant, not water-soluble lab apron. If I'm mixing up and diluting concentrated acids, I use this. Otherwise, most of the time, I just wear my lab coat, okay? So I'm going to scroll down to some more of these safety guidelines. I don't know why my computer is not talking to me. Okay, so number 9. Read the labels on all chemical bottles before use. Everything in the lab must be labeled. If it's not labeled, I have a few things that may not be labeled, and even most of them are labeled. If it's not labeled, it's water. This actually is still labeled. It's DD, distilled, deionized, or double distilled water. But nothing goes unlabeled or unnamed. And I try to put the concentration and the date it was made on it as well. Remove only as much chemical from the labeled bottle as needed. Do not return unused chemicals to their original containers. And that's a pretty standard procedure. That's not as much for safety, although certainly mixing chemicals, if you put it back in the wrong container, is dangerous. But it's just to prevent contamination. So if I take a chemical out, weigh it, and I have some left over, I don't put it back in because we can't guarantee the cleanliness of whatever you used for measuring, and it's just introducing contamination. Exercise caution when using a laboratory burner. Tie back long hair, make sure clothing is at a distance. That is a good rule. Keep flammable liquids away from heat, spark, and open flames. We're going to talk about that one. This is a laboratory burner. This is a gas petcock. It turns the gas on and off. In today's modern chemistry lab, that gas supply is also controlled with a lockable master valve shutoff over here. We adjust our Bunsen burners. This is technically a Terrell burner. It has a wheel to control the amount of gas going through here. This petcock is on-off. It is not for regulating the gas. You need a regulator or a needle valve to be more accurate with that. This is your normal welding striker. This is called the bell. You trap some gas in the bell and spark it. We'll talk about lighting a burner and what kind of flame we want later, but you can see I can adjust the flame up and down. And when we turn it off at the petcock. Okay? A long time ago, I assume nothing anymore. A long time ago, when I was teaching it was actually not a chemistry lab, it was a bacterial physiology lab in Texas A&M University. I had a student, I came into the lab as I was going home to check everything. It had a refrigerator that cycled on and off, and the room was filled with gas. Luckily, we were in the old biology building at A&M, across from the library, and it had classic windows that you could open. I opened up all the windows, yelled at the other graduate student in the university to keep everybody away and out, and aired out the room as quickly as I could. And I came over afterwards, and what I heard was the hissing of a burner on a bench top. And the next week I went to that student, I said, what were were you doing? You left your burner on. You didn't turn off the gas at your burner, you know, you didn't turn your burner off, your Bunsen burner off. And she said, yes, I did, I blew it out. That does not, you know, it's not a birthday candle, that does not end the gas. You can blow them out, but the gas is still going, and it would have blown out the side of the building if that refrigerator would have cycled or a spark would have happened. So, be careful. Never leave a lit burner unattended. Always turn the burner or hot plate off. Here's a hot plate. This is a new ceramic hot plate, new style ceramic hot plate made by Corning. The ones I grew up with had stirring and heat. And so we use these quite a bit, but you can't tell whether that's hot or not. The same way when you heat up glass, if you do any glass blowing or bending of tubes, or, you know, I took a graduate course in glass blowing, graduate seminar course when I was at A&M, and we had some great glass blowers there, real craftsmen, and it's an important skill if you're in more biochemistry and organic chemistry, when you have to make condensers and specialized equipment, extractors and the like. But you can't tell just from looking at glass if it's hot or not, unless it's red hot, of course. This new style burner, I've turned it on. Zoom in over here, and you have to zoom in, but walk up and get this dial, please. Okay, and even when I turn it off, there's a warning symbol that it's lit. But what if somebody has heated this up, turned it off, and unplugged it, and removed it from the power? Then you don't know if that top is hot or not, and they get incredibly hot because that's a ceramic that can go to many hundreds of degrees Celsius, let alone Fahrenheit. So, one thing we skipped was disposal of leftover chemicals and reaction mixtures as instructed by the instructors. Don't pour chemicals down the drain. Don't put leftover chemicals in the trash. We'll always have chemical disposal and tell you where it needs to be put, in a bottle, in a container, in, you know, a bucket, etc. Hot plates, heated metals remain hot for a long time. Allow them to use cool. Don't use glassware that's cracked or chipped, for when you heat it, it will heat unevenly and potentially crack, break, and even, I've seen it even explode. Do not handle broken glass. If you break something, use a brush and dustpan to clean up broken glass and put it in the broken glass disposal. If you look around, I didn't point it out, but if you break something, and we break stuff all the time, these are stone tops, they're chemically resistant, burn resistant, you can put hot stuff down on them without a hot bath, but they are unforgiving when it comes to glass. I tend to buy the thick wall, you know, better glassware, but when it breaks, don't worry about it. If you drop it, don't grab for it. Let it break. You pay a lab fee, we will buy a new one. They're not that expensive. Trips to the emergency room and stitches are. And I will clean it up. Don't worry about cleaning it up. There are brooms and dustpans, and if it's on the bench top, small whisk brooms and dustpans to clean up broken glass. And of course, we dispose of it in the broken glass trash. So, the main thing is be safe. Don't worry about broken glassware. Be in the moment, be aware of your surroundings. I'm going to talk about that next with a question and assignment for you. And wash your hands thoroughly with soap and water before leaving the lab. We have hand washing sinks, and labs that don't have a hand washing sink, go to the bathroom. The joke was always you could tell the chemist in the college when they went to the bathroom, they wash their hands before they go to the bathroom. You don't want to contaminate yourself with anything that you've gotten on your hands. Now, a while back, and I'm going to ask you a question about this, there was lady who was teaching kindergarten in Houston and saw a really cool experiment demonstration on YouTube. Thought it would be cool to show her kindergarten class the colored fire, colored flames. We do this experiment. We're going to do it a couple experiments from now, where we take different chemicals, put them into a flame, excite their electrons, raise them to a higher energy level than they're allowed to be in. As they decay back to ground state, or the level they're supposed to be at, they shed that excess energy as heat and light. And this demonstrates the quantum nature of the atom, because that chemical, that element, gives off a very specific wavelength of light, indicating that the jumps in energy shells is very specific. That you don't roll down a slope, but you step up to different energy levels, and you emit light at very specific wavelengths corresponding to very specific energies. And we'll use Planck's constant and some equations to calculate the energy levels of various colors of light as well. So she said you could take methanol. Here's some methanol, methyl alcohol, very clean, burning, simple alcohol used in, you can buy it in restaurant supply stores. You also can buy it as a gas preservative for gasoline engines. Removes water from gasoline engines, but I'd like you to notice a couple things. One is that this bottle doesn't sit flat. I'm going to talk about that in a minute. And when you open it for the first time, don't back up. When you open it for the first time, focus on this, and see if we can do it. I'll be quiet. I don't know if you heard that little pfft. But there's pressure building up in these. That's going to become important later on. And she thought, oh, if I mix boric acid, which is, you can get it in borax, sodium tetraborate, the element boron in borax, or you can get it in a roach preventative killer called boric acid or roach proof, which is just boric acid. And a stir bar. So I put this into a watch glass. Could you turn the lights off for me, please, so I can show this a little better? And over here. Here. So what I've done is I've added a little bit, come here and focus down on this. Here, I'll move the books, okay? No, you come close and focus on it. So, this is just methanol with boric acid, and it has green flame, okay? And this is foolish and dangerous, but it burns relatively coolly, but not completely, because I have a few tricks, okay? Do not do this at home, but if you notice, when I do the typical things an adolescent male would do, I guess, I'm holding my finger up, the heat's going up, the flame is not, burning me, and it will burn if I leave it on there long enough. It doesn't burn super hot like other things might, but it is burning. And if you look at it, it is green and pretty. But if you notice, I did some other things that I'm going to ask you about to make this much safer than we started. One thing I didn't do that would have been safer would be to have another one of these watch glasses so I can put it out. So you can just stay focused on that, and I'll get a watch glass out of the cabinet. So you see my watch glasses here. Let's see if I can put it out with another glass. Like so. Should have had that ready. So, I'm going to give you a link. No, I'm not going to give you a link, but you can look it up. Here's what happened in Houston for the teacher who decided that she would do it. So, go ahead and show the screen. Turn the lights back on, please. Hey, turn the lights back on. Turn the lights back on, please. Here's one. Houston area fire officials say 6 children have been hurt during a science experiment that caused a small blaze at a preschool of all things. That the experiment was being conducted at the Yellow School in Bunker Hill Village. It's a Presbyterian church school. The children are in good condition. Several children were released to their parents, but some of them weren't. And what happened in this experiment is, or this demonstration, is that, I can't find the rest of the story. It said she was demonstrating and a number of children were burned because she didn't do what I do. She didn't take my chemistry course. She got some methanol, she got some boric acid, she mixed them together, and she caught the entire bottle on fire. Remember I said it was not, see this bottle is flat. The bottoms of these have bowed out. They're like those weeble wobbles that wobble but don't fall down. It's that way because this has what's called methanol has a very high vapor pressure. The bottle in the atmosphere above the liquid has evaporated methanol in it, building up, increasing the pressure. The methanol vapor is increasing the pressure in the bottle such that when you open it, psst, you release the pressure. But it also means a lot of methanol goes into the air and is capable of catching fire. And that's what happened. She lit her sample and then caught the bottle on fire. The bottle exploded and threw flaming methanol over preschool kids. Not preschool, pre-kindergarten kids. Pre-K kids. So she ruined a lot of lives that day, including her own, because she'll probably never teach again. But imagine how horrible a kindergarten teacher would feel to harm the children she was in charge of. So this is why, 2 things, you have to follow the rules. And number 2, you have to learn how and why things work the way they do so that they don't go wrong when you don't want them to, and so that when they do go wrong, you know what to fix and what to do things for. So, think about the safety, take the safety quiz and answer the questions, respond in your lab report on this to the question I'm asking about this incident. I'll give you in the question a clue to search for it and find the information you need. And I'll post the next lab in a few days, and we'll continue to do some video labs that you'll answer questions about and fill out reports on. So until then, stay safe. Goodbye now.